Hello, everyone, and welcome to another episode of Hacking with Friends. Today, I'm on with my friend Stefan, aka Space Student, and we are going to be taking a look at the Wi-Fi duck and just how you can take a software idea and turn it into a more durable hardware project with a custom PCB. Now, a printed circuit board or a PCB is something like this right here. It is a silicon PCB, a printed circuit board that has copper pads and some traces that connect all these together. And really, this is taking the place of wires. If you wanted to see basically the same kind of setup in a different configuration, you could go ahead and put everything on a breadboard like this and connect everything using just a bunch of wires. And the drawback to this is, well, for one thing, you could get the different connections wrong. If any of them come out and you plug them back in and you get it wrong, you can fry the boards. There's durability issues where if you were going to intend on using this and suddenly one of the wires came out, you would have to quickly remember how to put it back in. Maybe it's dark and you can't see. So this is not very durable. And of course, this just comes really readily out of the breadboard if we wanted to. The microcontroller can just come loose like this. So if we want to create something that's a little bit more durable, then a breadboard probably isn't the best way to go about it. But in the project we're going to look at today, we're actually using two different microcontrollers that are stuck onto each other using the printed circuit board. And really what this is doing is allowing us to create a hybrid device that lets two devices, two microcontrollers, communicate with each other in order to make a third kind of bigger thing, which is the Wi-Fi duck. And we're using the ESP8266 microcontroller, which is allowing us to do a Wi-Fi interface, and an ATmega 34U microcontroller, in this case the SmartPhone Pro Micro, and we're using that to simulate a keyboard. And together we get this awesome keystroke injecting tool that allows us to have an awesome Wi-Fi interface and also basically act as a USB rubber ducky, but with a lot of extras in terms of being able to store scripts, run them, and have also a command line interface. So thank you, Stefan, for joining us and sharing with us a little bit about how we can take this sort of project and make it more durable and last longer. Can you tell me a little bit about your experience with trying to use a PCB like this to make a project maybe just a little bit better for people that want to make their own version?
Sure, yeah. So I guess I could just start with the Wi-Fi duck, as you mentioned that as an example. So I don't think we have to go that much deep into the whole Wi-Fi duck project. We did other streams about that. But basically here I created a little PCB, since the project, as you can see here, usually takes two microcontrollers, as you already mentioned as well. But wiring everything up is a bit, it's, you see all those dangling wires, and it's not really a good thing you want to carry around, because all of these cables could be easily, it's just like not a single tool you would want to use. And so of course you can
I can say that also.
Yeah.
We just did a class using the Wi-Fi duck where we had, I think, close to like 25, 30 participants. And out of those, we shipped about 50-50 the printed circuit board, which we pre-soldered, and then also the unsoldered one that is all kind of like stuck together. And within the first, I want to say, 25, 30 minutes of the class, somebody already managed to fry this one by plugging in the power and ground wires inverted. So they got their microcontroller super hot and it ended up burning itself out, and we had to send them a replacement. So, I mean, one of the big advantages here is mistakes. If you know the way this is supposed to go, you pay attention and you create it one time and you solder it down and it's on the circuit board and it's not going to move, then you're never going to make a mistake again of connecting like power to ground or something if it comes loose and ended up just destroying your board. So it does happen. People plug in the wrong cables all the time and end up frying their microcontroller. So one of the big advantages here is that once it's set, you're never going to have that risk again of destroying your poor, precious little microcontroller.
Right, so the idea is we want to take this breadboard, which is kind of dangerous, so to say, and want to put it together as something more permanent that can't easily change. So it's more like stable, like a stable piece of hardware. And while you can solder those pins with like some wire you can cut yourself together. That works, and then just like hot glue those two microcontrollers together. I did this a lot of times. It works. It's fine. It's just not as easy, and it can create a lot of headaches. But if you can make a little PCB, and that's what I did in this example, here you can see it. This PCB basically acts as a little sandwich in between those two boards. And you just plug them in with the header pins they come with if you buy them, because those are like off-the-shell development boards you can buy from China or even like on Amazon and stuff for really cheap. Then you basically just plug them in and solder those pins that are sticking out here, and that's it. Then you have it. You don't have to like look up which pins to connect to which other pins again, because that's done on the PCB for you, and you can just relax, solder those pins, and have something stable without needing hot glue and dangling wires and it's just way more durable and very easy. And for this project, this is really like a perfect little addition, because it makes the whole DIY process much easier, and making those PCBs is pretty cheap, and we don't need any more components, because basically we just connect 4 different wires and that's it. And for that, this PCB is perfect.
I was going to say also, this whole project is perfect for beginners who have never designed a PCB before, for a couple of reasons. One, these are off-the-shelf components that you're just sticking together basically. So there's not a lot of like surface mount soldering or like anything that would like make someone who has never created a device like this a little bit more uncomfortable in jumping in. Second is there's only 4 pins that matter on this. Every other pin could be completely messed up, and it wouldn't really matter on this PCB, because this project is really only linking 4 pins together. We're linking power to power, ground to ground, and then we're linking 2 different pins that are going to communicate and allow the 2 boards to talk to each other using IC squared? Mm-hmm. Which one?
Yeah.
Oh, okay. All right. So
I squared C.
What's I squared C? Yeah, neither of the ones I said. Okay. Yeah. So what's cool then is that this is a very, very simple way of combining these 2 boards. And you can also, of course, pick up the full Wi-Fi duck development board that was made by Travis Lin. But, if you just want to create your own and you don't want to spend like $30 on it, yeah, you can see that he's made one that's much smaller and kind of like a cool way of just supporting the project and also being able to have it all in one with the NeoPixel. But, if you just want to make your own and you want it to be as durable as the Travis Lin version, but you want it also to be cheaper and a little DIY, I think this project just goes to show how easy it is for someone who's never made a prototype before to create a printed circuit board, solder the 2 microcontrollers together, and then have this awesome, very durable kind of cyber weapon that is from this project that is really modular and has a lot of ability to just jump right into it and start working with it. That could be with a breadboard, or if you want to take the next step here, you could just make your own print circuit board. So yeah, let's see how easy it is to do that.
Yeah. So well, I guess I could just show how this looks like in the editor. So what we see here is the PCB for a VMOS D1 Mini. That's the bigger one, and the Pro Micro. So I'm just going to open that project. That should be this one. Let's open the schematic. Yeah. So this is.
So also, can you mention just a little bit about the program you're using?
Right. So I have Easy EDA open here. This works in the browser, and I really like this because it's just so that simple to use. You don't have to install anything. You don't have to worry about like licenses or paying something. You just go to their website. I'm not even sure if you need an account, but it surely helps having one since you want to save your projects. I think they also have now a standalone version where you download it, but it's basically just like a browser with the website open. Not sure, I haven't tried that out. But it works completely in the browser and is free to use. And of course, it's not as powerful and not as fast. And and all that, but it's just simple to use. It doesn't it's just more simple, more reduced to what you really need. And for bigger projects, sure, I would recommend using KiCad, another Eagle, genau. Yeah, Eagle was the other famous thing. And then there's also Altium, but Altium is very expensive. But yeah, those are like the big names when it comes to PCB development. This is more like the noob version, but I really like it because for simple things that I do, it just saves me time. And it also makes sharing projects easier because I have my project here on the left side. You can see all my projects. And this is public. So I have a link on the GitHub page. I think it's here. Yeah. So you go to easyeda.com/Wi-Fi duck. And then you can actually see this generate the Gerber files, which are like the compiled files you would send to a manufacturer yourself. And so this is basically like the source code. And by having this here, it's very easy for me to share the source code. So this is like a little GitHub for PCB design as well. And people can essentially fork this as well. So they could edit this project on their own account, I think. Yeah, they can. This is public. They can use this project to see how it's made and everything. And yeah. I just think this is a way more beginner-friendly program.
Definitely, because I used Eagle in my electronics class, and I never successfully finished building a PCB because for one, we were using a version of Eagle that was really old. So our classroom had like Eagle 2015 or something. So we couldn't use all the instructions on how to use it were actually out of date and stuff. What I love about this is it's free. Lots of people I know use this, and it seems like it doesn't take too much to get started because you can just take something that someone else has already done, import it, and then have something to just start spinning off of right away without having to start something from scratch. But seeing as I've never actually done one from scratch before, not meaning going over from scratch totally, but how do you go about just creating a new PCB design in a program like this? What is the process like if I've never done this before?
Right. I guess I can just create a new project real quick. So I guess we could just, cool. Should we just recreate this one with the Pro Micro and
Vimos? That'd be awesome. That would be really, really cool. And if anybody also wants to slap two microcontrollers together, then this is kind of just a guide on how you can do that on a scale that's, very scalable. Because you can make these PCBs very, very cheaply and then sell kits or do whatever you want in order to just combine two things that might otherwise need either a lot of soldering or a lot of wires to get working.
Yeah. All right. So I already went ahead on the left side where all my projects are clicked, right-clicked, new project. Just gonna name this basically as the old project, but copy at the end. So yeah, I'm an owner. Apparently you can also create teams and set a description. I'm just gonna leave it as it is and save. And now, I'm gonna close those tabs. Okay, now I should be... Oh, this is not saved yet, right? So it creates a new schematic file. I'm just gonna Control S to save. Right. Now I have this file here so this is the project folder I just created. And here we have sheet 1. And I'm just gonna quickly modify this and call it schematic. So this is a bit more obvious what it actually is. Here in the bottom, you can also rename it. You can enter your company, when it was made, the revision, all that metadata you care about. The important thing we have to do now is basically pick our components, first of all. And one other thing I love about this is just how easy that is, because in other design software for PCBs, this can be quite a headache if you're starting out. I'm just gonna click here on the left on libraries, and now I'm just gonna search for components. So we want a Pro Micro. So I'm just gonna enter that and search. Okay, there's a lot of stuff. Let's go. So you have different tabs or like selections here for different parts of that search. So workspace, I guess, is what you already have in that project. LCSC is a supplier for parts where you can actually buy parts. This is actually connected to EasyEDA, same as JLC PCB. They have a very good integration here. I think they all are part of the same company network. That's why you also see JLC PCB assembled. So those are parts the assembly service of JLC PCB supports. Not sure what system is, but hey, there is a Pro Micro. If you can't find anything, you can also always go to user contributed, and that's where the community puts their designs. And that's what I love so much about this, because you can mostly find any component here, because someone will have made it, and you don't have to search on the internet for it. You just search for it here and you will find it here. And that's just so convenient, because when I started out learning Eagle, I had to install a bunch of libraries and then still had a really hard time finding the components I wanted.
I could never find parts in Eagle when I was doing schematics. It was really annoying because, they were supposed to appear, and then I had a Mac OS version of Eagle, which was just not working the same way as the original version did. So yeah, it was really frustrating mostly because I couldn't easily pick parts and put them onto a schematic I was building.
Yeah. I'm just gonna, so if you choose something from user contributed in the bottom right, it will actually tell you this is user contributed, please check before using it. There's a lot of copies here as well. So the whole user contributed tab can be very obfuscated, just spammed with stuff.
Yeah.
The system seems to be quite nice. Here I have a Pro Micro 5 volt, and that seems to be the real deal. It's the SparkFun Pro Micro design. So I'm just gonna click on place, and here I have it, and I can choose wherever I want to place it and just click, and there I have it. I can place as many as I want, and when I right click, it's gone. I'm just gonna Control Z because we only need one. All right, now the other part. So I'm gonna go back and search for Wemos D1 Mini. Yeah, that's what I thought. There's no D1. Actually, let me try just searching for D1 Mini. Okay, lots of mini things popping up.
Yeah, that doesn't look related at all.
Let's go to user contributed. D1. No. Okay, let's search. Let's search for Wemos again.
Wemos.
Nope, that doesn't look. Always look on the right side. I want to see both a picture here, that's for the schematic, and one for the PCB board design. That's the second one. Either one look good. I'm just gonna. I don't know. This is user contributed. It's a bit weird how small it is compared to the Pro Micro, while in reality the Wemos is actually bigger. But
yeah, I noticed schematics don't. Yeah, there's sometimes just not that accurate. It's the PCB design that actually looks like the way it's supposed to be.
Just gonna quickly scale this thing. How do I call this? The border? Yeah.
The canvas?
Yeah, basically. I'm just gonna try to scale this down a bit. This was probably too much. This should be good enough. Okay. Yeah. So, now I have both my components, and if I go to the GitHub, here I can see under connections, I can see which pins I have to connect. So D1 of the ESP goes to 3 or SCL. Okay, D1 to SCL. So I'm gonna click here. This is the wiring tool. So that's how I make connections. D1, that's D1. And now I have to find SCL. Oh, there's no SCL here.
It's aliased as 3, I think.
So 3 would be same as D3. So
I could be wrong. I could be wrong. I might. You want to double check that?
It's 3, yeah.
Alias.
So
Okay, cool.
D2.
D2 is alias
So
to
2 to 2. Perfect.
2.
Bloop. So now I have those connected. Now we need to.
Cool. So now it can communicate with the other board. The two boards can communicate with each other.
Now we just have to make sure both are powered, so that when you plug in, for example, the Pro Micro, because that's what you want to do, because that's gonna act as a keyboard, then you want the VMOS D1 Mini also to be powered through that. So you don't have to plug in 2 USB connections.
And on the Pro Micro, the 5V is marked as raw, right?
Yes. It's marked raw because it will give you the raw power from the USB connector. So if the USB gives you more or less voltage, then it would just be that. It doesn't go through any...
so it's just saying it doesn't have a voltage
there's
regulator.
Nothing regulated. It's just like the raw power from USB. But yeah, that's 5V because USB is 5V. And I'm going to connect that to 5V on the VMOS. That's very important. Don't connect it to like 3V. That's gonna break everything. And now we have to connect ground. I'm just gonna make it really ugly now. And connect it like this.
Oh, right through.
Oh my god.
Oh my god, it's shredding all those pins. That would be
okay,
great.
so
just ground all those pins, including VCC.
So basically, we are done. We have connected all the wires we needed to connect. I'm just going to show you how to clean it up a bit more, because this looks kind of ugly. For example, instead of connecting ground to ground like a caveman here, we can actually here, where is it? Net flag? No. Is there no ground? Is this ground? Net flag ground. That should be, that's it, yeah. So we can just connect it here. Let's, oh god, it's gonna look ugly either way. I have to say I'm like no expert in this stuff. I'm just like self-taught and know enough to be able to make my projects. So basically what we're doing here is we give, how do you say this? We give those connections, those lines, or the line we had before, we basically give it a name. We give it a net, this is a net flag, did they call it that? Net flag, yeah. So it's basically a net, and everything that's connected to that net, and that net is called GND for ground. So everyone that has this net flag is connected to each other. So that also means I can.
So it's almost like algebra for PCB design, where like you create like a alias or like a variable for it, and then anything that's going to connect to the ground can just be, you can route it to that instead of physically routing it all the way over where it might need to go.
Yeah, and now I can also connect it to those grounds here, and it won't look as ugly as before. Although it still looks ugly because now we have those huge wires going through the entire thing. But before we fix those, we can just replace the 5V by using the 5V thing here. Where's raw? There's raw. Now we have that fixed. Don't want to move that. And so those are like pre-made net flags we can use for power. Those are just very convenient. We can also create our own. So for example, D1 goes to D1 is SCL, right? So let's just create our own SCL net. So here in the top net port, this, okay, both are ground. I could have also used that one. So whichever ground symbol you prefer. So I'm gonna create my own, and that goes to D1. Yeah. If you can move it like this and you see the line, then yeah, it's connected properly. Okay, let's call this SCL. What I just edited was just the label, not the net itself.
Right.
Oh, was it? No, I think it was the net itself. This is smart. Okay, cool. Then I'm just gonna select this, copy, paste.
To where you wanted to go on that
There
side?
you go. And now, just to make it a bit. Okay, now those are connected without needing those huge wires through the entire thing. We can also do it for SDA. So new net flag. I'm just gonna do it this way. No, it's okay.
Nice. So you can put it all together without wires. And you probably want to get rid of the ground ones on the left too. Unless we're actually connecting.
Wait. I'm still not happy with this. This looks kinda. Let me move some things around. I'm pretty sure some like actual hardware engineers are watching right now, and they're just like freaking out. It's like, what is this guy doing? Oh my god! I'm not sure if that made it worse, but worse or better. But oh god.
Do you need those two grounds connected?
No.
Oh, no, you don't. Okay,
No,
cool.
no.
That's looking pretty clean.
Okay. That looks way less horrible than our first sketch. Okay. So basically we are done. We have those pins connected. We can now try to actually design the PCB. So what we are basically, what we did now is kind of like write down the connections, but we didn't really design a PCB. We just said those parts go to those parts, or like those pins connect to that pins.
Yeah. So this is just like a rule book where whatever design we come up with, it has to match the schematic. Otherwise, it's not the same device, essentially, right?
Exactly. So I just did Control S to save it. And in the top here, there's a button called, I don't know what the button is called, but you can click here and then click Convert to PCB. It's gonna ask you like, hey, do we want to check your nets? Sure, why not? Right, so this is gonna show me a lot of errors because those boards, or not errors, those are warnings probably. Those development boards have a lot of pins, like here, TX, RX, reset, A0. I haven't connected those to anything. So the proper way to fix this is here on the wiring tools, select the no connect flag and just say
drop onto each one so it knows that it's not supposed to connect to anything. I guess is that just a warning to make sure that in case you did mean it to connect to something, you're aware of the fact that the connection is not made?
Because it could be that you look at this and you think everything is fine, but maybe one of those lines are not properly connected. It just looks like it.
I have a question then. Why are you connecting the two grounds on the left side of the Pro Micro?
Oh, just so all the grounds are connected to each other. I guess this is like good practice. You want all the grounds to be shared. Okay, save. Now refresh. No, nets refresh. Okay, great. Now all the warnings are gone, and under nets, you can see we have the 5-volt net, we have the ground net, and now when you click on it, it actually shows all those that are part of the net.
Oh, handy. So you can tell that they're actually all connected to each other.
Yeah.
With the labels.
Oh, look.
Cool.
Is this marked, or isn't this marked? Wait. If I click on 5-volt, this one doesn't get... Or is it? I'm confused. What is happening here? Oh! It should be part of it. 5-volt. Maybe it's just a display error, or I am blind or stupid. I don't know. But ground looks good, SCL looks good, SDA looks good. I'm just gonna continue and convert to PCB and see if it... All right.
Yeah, see if it works.
Save. Convert to PCB. Yeah, it looks like it did the right thing.
Okay,
yeah,
good.
because you can see here there's a line that goes to 5 volt. So I guess it's just like a display thing, like a display error. This can happen. I mean, this runs in the browser. Like, don't expect this to be perfect, but
The best.
it's beginner friendly, and that's the point. So now we are at the part where we actually design the physical PCB, and yeah, we have our 2 boards here, and now you can see those. What are those, like blue or purple
Ghost
lines?
wires.
Yeah, like ghost wires. They tell you where you need to go, and you can just... Let me just place those side by side to begin with. And here I can again select the... Oh, now it's called track tool, but it's very similar. You click on the pin that needs to be connected, and then you just draw a connection. Oh, come on. All right, that looks... We're not gonna win any beauty prizes, but that's fine. Oh, this is a tricky one. Well, we can go... oh god, that's gonna be ugly. Oh, whoop, whoop. So we can do even...
That's
yeah,
horrible.
that's extremely horrible.
Wait, does this have auto routing?
Oh! It should. I think I never used it.
Isn't that like the whole benefit of this? Auto router right there. Yeah, try it.
Sure, just run. Oh. What? Let me save first.
What?
Now again. Run.
I'm excited to see.
I never tried it.
If it's actually worse, it's going to be very funny. So for anyone who has done electronics, the auto router is usually a lifesaver, because what it will do is it basically looks at where you place your components and develops an optimal route, or just crashes.
It's like complaining that it doesn't have enough resources.
Oh my god, that's amazing. Well, yeah, so usually it's a life-saving tool that allows you to automatically create efficient routes on your printed circuit board, but in this case it just crashes.
Well, we can start by connecting the easy ones, like ground, like this. Right, so is it? Yeah, it's small enough to go between. Okay, this is... You don't want this. You don't want 45-degree angles, because it can act as an antenna or something. I'm really not an expert.
Huh, I didn't know that. So also what we're doing here is basically deciding where, when this printed circuit board is made, exactly where the etching needs to happen to lay down basically these tiny copper wires to connect all this together. So printed circuit boards are actually pretty amazing. Like, you take this wiring that we have to do, and then with programs like this, they can make it happen for incredibly cheap. And I don't know, I just think it's really crazy that like you're just literally laying down exactly where this board in the future would be chemically etched, and then have copper wires added to it, and then a silk screen put on top of it for insulation and stuff. It's just interesting.
Right. One problem right now, whatever I want to connect, I either have to do something like this. Horrible. Don't ever do this. Also 45 degrees everywhere. Not good. But I have to go like all the way around it, because there's another red line here, and I'm not allowed to cross it. If I do, that means that pin 3 would be also connected to ground, and then everything is a mess. Don't do that. But we can fix this by just going to the bottom layer. So the PCBs we're gonna make are 2 layers. They have like a top layer where you can draw those connections, and a bottom layer. There are also 4 or more layered PCBs you can buy. Those are usually more expensive. Yeah, those are like different, basically like different levels where you can draw your connections.
So if something would cross on one side, we can get away with crossing it here by just switching to the other side of the printed circuit board. Cool.
Like this. Still not the most beautiful, but for the sake of just showing how.
Yeah. It's not a beauty contest. We just want to show a quick and dirty PCB.
Right. Now I didn't really paid attention. Now I have another line that's gone across. But I can fix that too. So you see I can't draw over that other blue line. That's not gonna work. But we can essentially create a bridge over it through the other layer. Where is it? Is this it? No, pad.
Are you making a via?
Yeah, there it is.
What a crazy... Okay, so yeah, if you want to cheat and you're an electrical engineer, you can create a via, which is basically a drilled hole through the board. Ooh. And during production, what happens is they actually plate the hole so that you can get a connection between it. So yeah, you can go from one side to the other side of the board. You can basically burrow through the board using a via. Very tricky, Stefan.
Yeah. I wanted to show that this is also possible. So you don't have to work on just the layer or on just the one layer you decided to work on. You can switch between them. Oh my god, this is gonna be like the most ugliest routed PCB I've ever made.
This is such a crazy Frankenstein PCB.
But for the sake of
love it. But we're
showing how this works, we are gonna create this Frankenstein, no problem.
So anytime it's about to cross, it just switches to the other side of the board.
Oh my god, this is so ugly. Never do this, okay? You're gonna spend a lot of time trying to make this as beautiful as possible, and that's fine, but we don't have the time today. So
Right. And the actual version of the Wi-Fi duct, of course, is actually the two components are sitting on top of each other. But that would be pretty confusing to show off. Yeah, there you go. You can see they're just sitting on top of each other, but that would be pretty confusing to show off for just a beginner point of view. And also, there's no vias in the actual version. Vias, I believe, also increase the cost of manufacturing the PCB a little bit because they have to be plated on the inside, and that's kind of labor intensive, or at least time intensive.
I never heard of a manufacturer that asks for more money for vias. But
I just know it's one of those features where if you have a lot of them, it can increase the price of the PCB, or at least make it so you have to have certain production processes go into it in order for it to come out right.
Yeah. So sure, like you on the final on the PCB I made, I would take one of those boards, and on the right you can see those attributes. You can change some settings. I would move it to the bottom layer. And then I would move it on top of the other thing, the other board, and then route it again. That's how I did it. But for simplicity here, let's keep it like this. So both are on one layer.
Yeah.
You see that what is this, pink, purple? I'm really not good with colors. Line. That's the board outline, right? So that's basically the size of the final PCB. And we have a lot of empty space here, so we can actually make this much smaller. Oops. This. Yeah, okay.
So that's setting the actual size of the circuit board that would be created.
Yeah. Oh my god.
Cool.
Trying to concentrate on
making the line straight.
That's all. Okay. Good enough. Good enough for me. So we can actually get a preview of our PCB by going on the top. There's this little camera icon. So you can go to photo view. That's rendered pretty fast.
Whoa, that's really fast. That's cool. All right, so if we didn't care kind of which way this was facing, or if we didn't want to optimize the way that it was, and we just want to stick two PCBs together, that's a really easy way to do it. That's really cool. The V is also crazy. It looks like some of the the traces just go nowhere. But that's just because they're crossing over the other side.
We can go to the bottom side. Here you see the other traces.
Ah, yeah, I see them.
Yeah.
Cool. So then this is something that we can actually go ahead and have produced, right?
Right. I want to show some other thing as well. So
sure.
First of all, you can also click on 3D view. This takes longer to load, and depending how complex your PCB is, this can actually load for quite a while. Yeah, now you can actually see it in 3D. Quite nice. Another thing is maybe sure, you can move those things around here. You don't want to have that cut off. You could also draw rigid arc. You could try to make this oh god, rotate. No, this is okay. I'm annoyed, but I just want to show you that it's possible to make those edges rounded. You can actually make this PCB the shape of whatever you want. And I have another project. Maybe I can show that real quick. Right. You have seen that PCB.
Ah, the hack and batch. Yeah.
You can see how long it takes to load. It's because that shape is so complicated. I'm gonna you can see, you can basically make the board outline whatever shape you want. So you can actually make some artistic designs with that. You can also add text. So it's like hello world. This is currently on the bottom. We want this on the, let's put it on the bottom silk layer. And then let's just put it here. By the way,
so this is also how you put like labels and like things like that on your board, so that when it's produced, it has maybe additional information.
Exactly. On it. So there are different layers here. You can always select. Top and bottom layer are those two layers where you would draw the traces. So those are the connections. You have the silk layers. That's where the those additional like text, that kind of stuff is drawn. So that's basically like it's just like something printed on the thing, like a text or like board outline or where to place which component, whatever you want. It's like a printer. Bottom silk layer, of course, because you can print on both sides, right? You also have those paste layers, solder mask. That's where the where those like areas where the copper is exposed and that kind of stuff. Usually you operate in those top, bottom, and silk layers and leave the other stuff alone. And if I render this now and go to the other side, there it is. Hello world.
Hey, that's awesome. And again, this is where people provide instructions for maybe which side you're supposed to do first, or like any other thing they want on their project, so that people are aware of, maybe some instructions that are just critical, like which side to solder first.
Exactly. And then one last thing before we go to the manufacturing, you can, so right now the PCB, again, like a PCB is made of different kind of layers, and that's also represented here by this selection. And right now, the only copper we have in this PCB are those connections. But what you usually see is a, exactly here, a copper area. You can select it. It asks you which net it's going to be on. Ground is usually the thing it's just like a common thing to create a ground copper area. I'm just going to create one and then explain what it actually is. I'm just going to draw it. It can be bigger. It doesn't have to be beautiful. Just like has to be bigger than a PCB. Or doesn't even necessarily, but we want to have it. And boom. Now, everything that's red is now copper. And why do...
That sounds expensive.
Yes. But why do we want this? This is now connecting... that's why it asks for the net ground, GND. It's connecting all those. So you can see here... actually how ground goes into that.
Oh, I see.
And
the circle is
and
open.
The other ones, they are not connected to it. So this huge plane shares ground. On more complicated PCBs, it's often used as you would have dedicated layers for those copper areas, where you have a single layer that connects all grounds and a single layer that's just there to connect all like 5-volt lines, just to have the power.
And this is a giant copper port?
Yes. So if we render this again, let me remove this again real quick.
It looks the same.
It doesn't. Okay, this is without it. This is with it. You see the subtle difference?
Looks like the ground plane is gone, or the ground traces are gone on one of them, for one.
Well, the traces that are gone are those that are connected to ground, because those are now part of this huge plane.
That's what it is.
But the color changes a bit. Because now below the color, the blue color that's actually on top here, or I don't think there's blue color printed on it. It's just the material that's blue then. But
yeah, just the silk screen.
Yeah, but because there's copper in between, the color changes also. Something to keep in mind if you're doing artwork. Yeah, keep in mind also.
Oh, solder mask, not silk screen. Solder mask. It's just the color of the solder mask, right?
Yes, I hope so. I hope we are not telling any. I hope we get most of the things right again. Not necessarily. We are not professionals. Just want to show how easy it is.
The most important thing is that these work.
Yeah.
Even a beginner can create something that works. It might not be beautiful. It might not be according to best practices, but you can get this. This board that we created, ugly as it is, will work. And you can get it produced. Not that you should, because there's better ones available, but I mean, you could, and you could make your own spin on this too.
I have to say, on the new PCBs I made for exactly this project, for the Wi-Fi duck, the first revision, the first PCBs I made, I had a ground pad area, but I removed that now because it means that when you're trying to solder those, when you're trying to solder pins to that ground pad, it means that your soldering iron that applies heat, that heat is now that dissipates through the entire PCB.
Huge thermal seep.
Meanwhile, if you just have the traces, then the heat dissipation isn't that big, and you can solder more easily because your soldering iron is hotter, right?
That's super funny. So one thing with printed circuit boards, as Stefan just mentioned, is soldering involves heat, and heat likes to flow into a heat sink. So if you have a massive copper plane underneath the solder mask on your printed circuit board, then it means that if it's all connected to your ground plane, you're going to be soldering all the other pins. You'll get to the ground pin, you'll try to solder it, and it's just like nothing is going to happen for a good couple of seconds because all that heat is being absorbed into this huge layer of copper. So some unexpected physical effects can happen as a result of these designs. It's really cool that you can make these with all these features that are really easy to implement, but then when you actually have them produced, you might notice some physical quirks when actually assembling them, such as accidentally creating a massive copper heat sink that then absorbs all the heat from the soldering iron, making it more difficult to solder pins in place. So interesting, interesting effect from adding a giant copper plane.
Right. I just want to mention this. My camera went out somewhere in this recording. I just turned it back on. Yeah, there's gonna be a black screen.
That's okay. I imagine we
just put the Space Hoon logo
at the PCB.
where my face is. Anyway.
Cool. So then we have this mostly finished PCB. What's the final step for actually being able to produce this and get it in our hands?
Right. So let's save it. So let's say we are done. Again, this is ugly. Don't do it. Spend some time making it nice and fancy. But if we say we are done, we can import changes. No, where is it? Oh, here. This button. I'm not sure what it is supposed to be, like a folder with a G and an arrow pointing outwards for like export, I guess. And G is for Gerber files.
Wow.
If you click here, similar to before where we generated the schematic. It's now asking to check the design rule check. Yeah, right. Checking the design rule check. That sounds weird. Basically, you have a set of rules that the PCB has to fulfill, like how big the traces can be or how small, how big the vias can be. They're like specifications, and each manufacturer has different specifications, and you can change those in the menu, but we can just keep those at default. The default ones should be good and work with any manufacturer really. For just starting out, just click on okay, and if you don't see any errors, this window will appear. It's gonna show you another preview of the PCB, and you can actually order it through this right now. So you can say, let me buy just 100 or just buy 5. And if you buy 5 pieces, you can see it's just $4. 10 pieces is even $5. That's good value. It's just so cheap.
Yeah.
And you can just click here, order GLC PCB. Yeah, it goes and forwards you to the GLC PCB site. Takes a bit. Yeah, now it's basically importing the Gerber files you exported before.
Wow.
Bam. You have another preview.
And then that's ready to order.
Right, you can now, so the layers and dimensions, that's imported. Don't change that, because that's, necessary to be correct, like with your project. But you can select now the quantity you want. You can select how thick the PCB shall be, and the colors, the color the PCB should be, surface finish. Those more advanced options are usually not necessary again for a beginner. One thing that's maybe important to check out is remove order number. So if you have this set to no, it means that some place on this PCB, the manufacturer will put a little like serial number, just so they can distinguish your PCB design from others and know what where it has to go, like which PCB is part of which order. But you can say yes. I think it costs a little extra, €1 more. Really not much, but then they will. I'm actually not sure what they will do internally, but they won't
blast it off with the laser or something.
They won't put a serial number on your design. This can be really important again if you're doing artwork. If we are doing something like this, then we don't care. You can also specify location. That would mean you have a piece of text with a certain value already placed on the PCB, and the manufacturer goes in and just changes that text to their serial number. So you can also specify location, essentially, where you want to place those. So that's something to look out.
So if you were designing a PCB where you were going to maybe remove a part of it, or like have a part of it that was like sanded off or something, you could maybe then put the part that you don't care about, the serial number from the manufacturer that helps them through the manufacturing process, some of them might get removed or something.
Exactly. But that's it. Again, like you can also leave all of those to default and just order your first PCBs. It's going to be incredibly cheap at GLC PCB anyway. Basically.
Wow.
That's it.
Awesome. Okay. So I, as I said, went through one class where I learned a little bit about designing printed circuit boards, and I got to take a tour of an actual factory in Southern California that makes printed circuit boards. So I know that the process to make them is pretty crazy, but the front end ability to just go in and, as a beginner, take a look at someone else's design, maybe modify it a little bit, and then create my own printed circuit board that comes to my house for like, a couple of dollars. That's crazy. Like, that's really getting to the point that anybody who's willing to even just sit back and watch this video could make their first printed circuit board, especially for something simple as the Wi-Fi duct. And, we've iterated the design a little bit to include other circuit boards like the Beetle, which is another alternative design to the Pro Micro that I like very much. And it's the one that's on this little breadboard. I like it because it has a USB type A adapter where you can just plug it in and get it ready. So, we just threw ahead. Oh yeah, no, you can see here. We created something that is basically totally capable of being a very, very small version of the Wi-Fi duct that uses a different microcontroller. So if you have maybe another microcontroller you want to connect to the ESP8266 and make your own project like this, or if you just want to try out a super, super, super tiny Wi-Fi duct, then it seems like the process of getting started with designing your own printed circuit board to make your own hardware prototype that's more durable, and hopefully you won't accidentally electrocute and get the wires in wrong, as had happened with the breadboard version. It's really simple to get started. You can just open up Easy EDA, you can create a new project or take a project that someone else has already started, and you can make your own printed circuit board that then you solder together and have this awesome tool that I think is really unique and really, really a good way to learn about how electronics are made. So fun. Thank you so much for showing us how this works, because again, neither of us are professionals here, but the circuit boards work, and I've already done a couple workshops on them and people think they're really, really awesome. So thank you for spending the time on showing us how someone, even a beginner, would go from start to finish on designing a printed circuit board to create their own hardware prototype.
Yeah, no problem. Oh my god, I think I just crashed the oh, it just crashed Easy EDA. That can happen. Oh, no, there it is.
It's free.
So just before we go, just want to show off, like, you can create beautiful things like this. This is a super easy, like simple design. It's just a couple of LEDs connected to a battery and an on and off switch. That's basically it.
And you even made a space to solder a pin to.
Yeah.
So this is designed to like be pinned on someone's like bag or on their shirt. And you were able to make a copper pour on the back that's really easy to solder, just a common pin to. So you can wear it like that.
And this is this is what I love about PCB design. You can create these like beautiful things that are still super simple, but it's like next level. You're creating your own thing, but it's still like in the shape or form you want to have it to. It's like something manufactured, like in a custom shape just for you, and you can get it so cheap, and I just love it. It's just really cool.
Yeah, for me too. I think artists and other people that want to create more than just functional prototypes, but also things that are just beautiful. I have a number of friends also that create jewelry where they'll make an LED printed circuit board that takes tiny batteries that is just incredible, and maybe uses some sensors to just like add a little bit of something extra to a piece of jewelry. So this isn't just for science nerds, and this isn't just for people who are making hacking prototypes. This is also for artists and makers and people who want to make beautiful things, because tools like EDA and the ability to make things through GLC PCB just mean that you'll be able to get started creating something that is truly yours and that nobody else has. And I think that for $5 or something to get that shipped to your house is really something that you should give it a try if you're interested.
Right. There's one thing.
All right, I think we're coming up on
There's
time.
one thing just came into my mind. What if you don't want to order from JLC PCB? You can create those. Instead of clicking here on order at JLC, you can also click on generate Gerber, and then it will give you that zip file you can download and upload to other sites. For example, oshpark.com, also a great site. They support open source hardware, and you can just drag and drop the zip file here and have incredibly high quality PCBs manufactured. Those are not necessarily as cheap, but they are made in the US, and the purple color, you would just love it. It's amazing. Yeah, just wanted to give a quick shout out.
Oh yeah, wasn't it like perfect purple or like midnight or something like that we saw demonstrated at C3 that were just absolutely beautiful? Yeah,
check them out.
No, awesome. Yeah, so if you are getting started with this, there's also options, especially if you're an artist or someone who wants to make something really beautiful. I know that Oshpark does some incredible PCBs, so maybe if they hear about this, they'll sponsor us to make some more prototypes and show you guys how they work. Would be pretty cool.
That would be pretty cool.
Just like elbow our people that we know. All right, we're definitely over our time for today, so we got to wrap things up. But we covered a ton today. If you've ever seen a printed circuit board and wondered how they work, well, now by watching this, you could probably just design your own. So thank you to Stefan for showing us how to, as a beginner, go from start to finish on a printed circuit board prototype and actually get it printed and sent to your home. I think that is amazing.
Yeah, thanks for having me. This was pretty cool, actually.
Cool. Well, thank you again also to Veronis for making sure this show is a thing. If you want to check them out, then go ahead and look at the cyber hack workshop, and it'll probably scare you into wanting to make sure your company's data is properly protected. If you want to follow this stream, you can always go ahead and go to our YouTube channel at SecurityFWD, youtube.com/c/SecurityFWD. We have all of these streams recorded, so you can go back and watch them. So if you weren't actually designing your own PCB with us, you can go back and do it anytime you want. You can also sign up to be notified when we go live. So if you like these, go ahead and hit subscribe on the YouTube channel. We'd really appreciate it. And of course, make sure to retweet this and share it with all your friends. All right. Hopefully you guys enjoyed that. We will see you again. And if you liked this PCB special, then let us know. We'll do some more maker style stuff. Just try to keep things fun and include a whole bunch of different things you might not have been exposed to before. So yeah, thanks so much for joining us, and we will see you guys next time.
Bye-bye.
Bye.